Hello guys, so today we will see how to implement a stack using a linked list. How to implement a stack using a linked list. So here we are using last in first out. First of all, what is last in first out? For that, just consider this as an example. Just consider I am having a stack of notes. Stack of notebooks. Means I am having a list of notebooks which is arranged one above the other. So I am having a stack of notebooks which is arranged one above the other. Then last in first out, which means that I can take only the last placed notebook as the first one. I will just repeat it again. I can only take the last placed notebook as the first one. That is called as last in first out approach. But how we can implement this last in first out approach or stack using a linked list? We already know that we can insert a node in linked list using two approaches. So we can insert a node in a linked list using two approaches. We can use insertion at tail. We can also use insertion at head. Here for stack implementation, I am going to use the insertion at head approach. So what is insertion at head? Suppose we are already having a linked list 1 and then the next node is null. If I want to enter a new node, for example 2, then it is added at the head. If I want to add 3, then it is added at the head. If I want to add 4, then it is added at the head like this. So we are using insertion at head approach in linked list to implement a stack. We are going to use insertion at head. I will write here. We are going to use insertion at head approach in linked list to implement a stack. So here in stack it will get added like this: 1, 2, and then 3, and then 4, and then like that it will get added in the stack. So we are going to, as I said earlier, we are going to use this approach, insertion at head approach in linked list to implement a stack. So instead of the variable name head, here we are going to use the name top. So instead of the name head, so here in linked list we call this first node as the head node, but here in stack we are going to call this variable as top. So here in this linked list head is 4. So in the stack the top is 4. So this is what we are going to, so for insertion or otherwise stack push, for stack push operation we are going to use the linked list insertion at head approach. For pop, simply we need to make top equal to top.next and then we have to retrieve the data. So how to do it in code, we will see it next. So now we will see how to implement a stack in code using a linked list approach. So first of all, what we need a node. I'm creating top node. So what is node? So we need to create a class for that node. So I'm creating a class node. So what is inside a node? So we will have a data and then pointer to the next node. So we have a data and then pointer to the next node. So I'm making it as next. So simply I created a top node. So instead of head in linked list, here we created, I just named the variable as top here. Apart from that, I created a node class. So a node contains a data and then pointed to the next node. So we are ready with the node. And then we need a constructor so that we can insert the data into the node. So I'm creating a constructor, then I'm pointing it like this dot data is equal to the data, which is this dot data refers to this data, and then whatever data which we are getting, so it will get automatically added to the node. So we created a simple node with a constructor. Okay. So next thing is we need to push the data into the stack. We need to push the data into the stack. For that, I'm creating a simple method. So here public, which has to return a stack, and then I'm naming it as push, and then so here I'm going to pass two data. First thing is I'm going to pass the stack itself, and then whatever data I just want to insert into this stack, I'm going to add. So this is the stack which we created. Okay, so it asks for a return statement for the first time. I'm just returning null. I will just repeat it here. So I just created a simple empty method. So here I took the stack and then the data as a input. So first of all, what we need to do for push or insertion. First step is we need to create a node. First step is create a new node with the input data. Create a node with the input data. So I'm creating a new node. I'm just naming it as new node equal to new node with the input data. So here you can see I just created a new node here. So with the input data. So automatically here it will go to the constructor, and then this data is got inserted into this node. So next thing is here we are using insertion at head approach in linked list. As I said earlier, insertion at head approach. So what is insertion at head approach? So for example, I'm having a linked list 1 and then null. So 1 and then null. So here we are getting a new node 2. For example, here we are getting a new node 2, for example. Then I need to make new node. I need to make new node dot next equal to top. Then top equal to new node. I will just explain this part again. So for push, I just simply created a new node with the data 2. We already know that 1 is top. So I'm making the already existing top as the new node next. And then I'm making the current new node as the top. So here already existing top is 1. I'm making 1 as the new node next. You can see here I'm making 1 as new node next, and then I'm making the new current node as top. So now we will see how to print all those elements. So simply for that I'm creating a simple method, public void print, and then what are all the inputs we need? We need a stack for that, so that we can print all those elements in a stack. And then I'm just making current node stack dot top is the current node, and then I'm using a while loop where I'm checking current node not equal to null. Current node not equal to null. Then I'm going to print the elements in the linked list. Elements in the stack. As I'm using the same approach, so I'm telling again and again linked list. So elements in the stack, I'm just printing current dot data. Okay. So it has to traverse to the next element. So I'm making current equal to current dot next. Okay, to current dot next. So now I'm creating a main method so that I can call all those methods from here. So public static void main of string arguments. And then first thing is I need to create a stack. So you can see here the stack which I mentioned here is the stack which we created now, which is not the inbuilt class. Okay, so and then first thing is I need to call the push method, stack dot push of I'm inserting nodes like 1, then 2, just changing it here, 2, 3, and then 4. So next, what is the next step? I need to print all those elements. So stack dot, I'm calling the print method with the same stuff. So here the insertion order is 1, 2, 3, 4. So in head I'm using insertion at head approach. So I need to get the output like 4, 3, 2, 1. We'll see how we are getting. So here you can see it is 4, 3, 2, 1. So we get the output like 4, 3, 2, 1. So I will just explain this one again. So simply for our stack implementation, I created a node class. We know already that our node contains a data and the pointer to the next node. We need in linked list we used head. Instead of that, here I'm giving the name as top node. So for the first method is push. So here I created a new node and then I'm making the new nodes. I'm making the already existing top as new nodes next, and then the new node as top, and then I'm returning the stack. Next step is I just created a method, print method, so where the input is stack, and then I'm just traversing the current node, and then I'm making the current node as current node next, so that I just traverse all the elements in the stack and I'm just printing all those elements. I think I made a spelling mistake here. So elements in stack, and then I'm calling all those methods in main method. So push and then print. So next the remaining methods are we need to implement pop and then peek. We will see how to do that. So now we will see how to implement peek and pop in stack. For that we need one boolean method which is returns a boolean, then it just check whether the stack is empty or not. Checks whether the stack is empty or not. I'm just creating this empty method. So here I'm going to check like if stack dot top is null, then it has to return true. Then it has to return true, or otherwise it has to return false. So now we will see the peek method. So peek method just returns the top element. So I'm just returning integer and then peek. We need 2 inputs, stack. I think stack alone is enough. So here to peek, first we need to check whether it is empty or not, whether the stack is empty or not. If it is empty, the stack is empty, then we need to throw exception. If the stack is empty, then we need to throw empty stack exception. In util. If it is not empty, then integer data equal to stack dot top dot data. I'm just getting the top data and then I'm returning this, which is the peek data. So now we will see how to implement pop method. So for that, for pop method also I'm returning integer, or otherwise it is not needed. So we removes and returns the data, populate data I think. So I'm just popping. Also I need input as stack, and then so I'm going to do the same thing. So I'm just copy pasting it. Same thing. The only difference is apart from giving the top data, making the top equal to top dot next, which means that the top element got deleted. The top element will get deleted. So here I will show you what and all things I did. So as you can see, I simply created isEmpty method, which checks whether the stack is empty or not. So I'm just checking it like stack top equal to null, then it will just return true or false. So for peek and pop operation, I'm just checking this condition. If the stack is empty, then it has to throw the empty stack exception, or otherwise In case of peak, I'm just returning the top data. In case of peak, I'm just returning the top dot data. In case of pop, I'm making top equal to top dot next, so that the top node got deleted, will get deleted, so that the top element will get deleted. So I'm just going to call all those methods. So first thing is I'm going to do stack.peak, calling stack.peak method. After that, I'm going to call stack.pop, and then I'm going to print all those elements. We'll execute and check what happens. Okay. So here 4321, and then I have to print this. Okay, I have to print this peak data, integer equal to, and then I'm going to print this one, data, and then I just give pop, which removes the top element, which is 4. Then we have to get the remaining elements as 3, 2, 1. So here you can see, first we are having the elements like 4, 3, 2, 1. We inserted data like 4, 3, 2, 1, and then the peak data or otherwise top data is 4, and then after pop we are having the elements 3 to 1 because it already deleted the top data, which is 4. So this is how it works. So we already saw how to do push also. So I simply created a stack class, and then I just included all the stack implementation in this class. So we created a node, and then we have the method push here. You can see that one. So we have a method push, and then I'm just printing all those elements, and then we are checking is empty or not, whether the stack is empty or not. And then we are having peak and pop. The only difference is in peak we just print the top element, it just returns the top element, but in pop method we are deleting the node itself. I will just repeat again. In peak we are just giving the top element, we are just giving the top element as output, but in pop we are removing the top element. So we are making here top equal to top dot next. So in this way stack is got implemented. If you have any doubts, please mention in the comment section. Apart from that, you can get this code in my GitHub account. I'm just giving my GitHub account in my description box. And then, yeah, thank you und haben Sie einen schönen Tag.